Welcome back to another edition of HVAC for beginners. In this section or segment, as we call it, we're going to be going over the refrigeration cycle. And it's the cycle of how the operation of the system works and the components that are in them. And we're also going to go over some of the aspects of it and kind of go over the details. We got some pictures to take a look at and some discussions to go over. So if you're eager and ready to go, you got your pen, your paper, you got your recording device, or however you're going to record this, guys, man, let's get into this enthusiastic part of phase one of the refrigeration cycle. Introduction to the climate control phase one, refrigeration cycle. The refrigeration cycle is a thermodynamic process that involves several components working together to transfer heat from one place to another. The main component of a refrigeration cycle includes your compressor. This component is responsible for compressing the refrigerant gas and raising its pressure and temperature. The condenser. The condenser is a heat exchanger that removes heat from the compressor or compressed refrigerant gas and converts it into a high-pressure liquid. The expansion valve is a device that controls the flow of the refrigeration from the high-pressure liquid state to a low-pressure liquid state. This process is known as throttling, and it causes the refrigerant to expand, which reduces its pressure and temperatures. Guys, I also just throw that in that, and also when it says change it from a high to a low, we're talking about latent heat as well. The evaporator. The evaporator is another heat exchanger that absorbs heat from the surroundings and evaporates the low-pressure liquid refrigerant into a gas. The refrigerant itself is the working fluid that circulates through the refrigeration cycle and undergoes a phase change as it absorbs and releases heat. These components work together in a closed loop to transfer heat from a colder place to a warmer place. The refrigerant absorbs heat at the evaporator and releases it at the condenser, with the compressor and the expansion valve controlling the flow and pressure of the refrigerant. So let's kind of go over a few things. I know that's a lot to absorb at once, but basically your compressor is a vapor pump. Your compressor only can compress gas. It cannot compress liquid. You might hear a terminology out there of a system that's overcharged. When a system is overcharged, that means it has too much refrigerant in the system, and instead of compressing gas, it compresses liquid. You will hear that phase as we go on through our studies. Also, there's one other thing that's missing out of here that's so important that needs to be introduced to it. It's called a liquid line dryer. And the liquid line dryer is a type of filter that collects trash. It is on the high pressure side. So if you ever get a chance and you live in a home, go outside and look at the condenser on the side of your house. That's what houses your condenser and your compressor. You'll see a little gray device on there. Kind of looks like an oddball looking bottle. And you'll see it on the smaller copper size. A lot of them, the smaller size is your high pressure size. The larger of the copper tubing is your low pressure or your suction side. And you'll see it mounted to the side of the house. It's designed to collect trash, and it's good for about 3 years. You'll see people leave them on longer than that. I don't suggest that because they will collect trash as the system gets older. But that's one thing that's missing from up here that needs to be addressed because it is important in the refrigeration cycle. So let's go ahead and take a look at a simplistic, easy diagram, and then we'll get to one that's a little more difficult, but it has a little bit more breakdown. Let's go ahead and take and start at the compressor. Now, I want you to start at the discharge line side. You'll see it's in pink. And if you notice, you'll see black arrows that are actually going in one direction. That is the way the refrigeration cycle travels. It goes from the compressor off the discharge line into the condenser. Now, if you go outside and take a look at one, you'll see the compressor sits on the in the middle of your condenser, and then there's this coil that's around the side. That coil is your condenser. And then there's a fan that's on top of it. So it'll run from the compressor, goes into the condenser coil itself, the fan, and then remember it said that it removes heat from one place to another. Now, it doesn't matter where we get rid of the heat. The whole key thing is that we're getting rid of it or dissipating heat. So if you ever get a chance to go outside while your system's running, put your hand over your condenser and you'll feel heat coming off of it. That's a transfer of heat. That's the heat being removed from inside to your house to the outdoors and dissipates into the atmosphere. That's why we don't care where it goes as long as it's out of the house. As it leaves the condenser, it goes in there, and it's basically a high pressure or a hot gas. Once it hits the condenser and you remove the heat, it goes from a gas back down to a liquid. That's called the liquid line. And that liquid line is the line that you'll see coming out that's going to go into your house. That's that one I told you that has filter system on it, your liquid line dryer. And it heads towards the metering device. Now, the metering device nowadays, it looks exactly like that. That is called a thermal expansion valve. Basically, it meters the refrigerant that flows within the system, and we'll go in more detail on how the thermal expansion valve actually works in the home related to heat load in your house. Back in the day, when air conditioners were coming out, they had what was called a cap tube system. So I want you to take a look at where the metering device is and think of 4 or 5 tubes, just depending on the size, the tonnage of your system. Some 4, 5, 6, they had these cap tubes that actually metered the refrigerant, but they were cap tubes, pistons, and flow raters had different sizes for different tonnage of equipment, and they only could meter for that load amount. So it would have a heat load measurement for that system, and if you superseded it or over expanded the heat load, the AC system couldn't be efficient enough and it wouldn't cool the house. Your temperature in your house would go up. So I'll give you an example. Say you have a party, and say your home is designed to take a certain amount of heat load, say 20 people at best, but you have 30 people coming to your home. Be expected for your air conditioning system, instead of maintaining 74, 75 degrees, to go up to maybe 79, 80 degrees, because it can't remove or adjust the heat load in your home to get it out. That's where the thermal expansion valve basically comes in. It is an adjustable metering device, so the more heat load you add into it, the more refrigerant it can add in to remove the heat from your home, the more efficient. Today's day, and now in our era, everything has a thermal expansion valve on it. As you see it going into the evaporator, it goes into the evaporator and it condenses from a liquid to a gas, and then it returns in the cold state. So the reason why the liquid line's in red, it's high pressure and it's hot. On the cool side, the one that's in blue and suction, if you touch it, it is cold. If it's running properly and you make a temperature reading on it, maybe 52, 53 degrees. It runs all the way back into the compressor, pumps it as the gas, goes back out the discharge line, and completes the cycle all over again. And that's how this cycle works. But let's go ahead and take a look at a more sophisticated form of cycle with gauges and meter, and I can kind of go over a little bit more detail. Not going to go too hard because there's a lot to learn here. If you see where my gauges are, those are called refrigeration gauges. It has a suction side and a high pressure side. In the middle is a little sight glass that shows you how, if you can tell if refrigeration is flowing through your gauges. It can also tell you sometimes if the refrigerant's burnt. You can see where go on the refrigeration gauges, the blue side goes over to the suction side, or the blue line of your refrigeration system, which is the low pressure side. The red goes to the high side, which is your high pressure side. And when it reads it, you're going to get a reading on pressure for low pressure and reading for pressure on high pressure. But let's go ahead. If you take a look also, you'll see your voltmeter used as a temperature probe. The one that you want to get, if you decide to get you one, I would recommend a field piece. A field piece is a little cheaper than the highest brand out there. They have a Cadillac version, but field piece is like the one I go for. It's reliable, it's wonderful, and it's half the price. It has a temperature probe setting on there where you can get a clamp on to clamp onto your suction side. As you see, it comes off the meter and it's making a temperature reading. The other one, you can, if you want, can run it oppositely off of that one and go over to your high side. So if you're doing readings on the cool side and you're charging it, that's called superheat. If you're charging it and on the high side, it's called subcool. There's a lot of debate going on out there that you can't superheat a system that has a thermal expansion valve on it. They want you to subcool it, usually 6, 7, 8 degrees. I beg to differ. I proved it wrong, and my college professor has proved it wrong, because here's why. Back in the day, there were thermal expansion valves out there that you could put in or sweat into a system, and we superheated it back then. You can superheat a system with a thermal expansion valve installed. All you need to do is make sure that you get a subcool reading and make sure that it's within the range. Some of the units, like Carrier, will put a marking on their nomenclature. Their nomenclature is their identification plate, and it'll have a subcool reading on there, and you just got to get close to that one. But I will go through a mathematical equation with you on how to do a subcool without using a sliding chart. The days of sliding charts and sling chronometers are over. We just don't do it that way. You'll see some people still old schooling in that way, and I will beat them every time with the mathematical equation that I learned in college and at refrigeration school. And it works, and I was taught by older guys out in the field that have been using it for years, and by God, it's 100% effective. So that's the system. So let's take a look at this one, kind of breaks it down. You'll see the compressor. Now, I want you to follow on the red side. It goes to the condenser. And then the little thing down there below that has a little circle below, it's in black, has some red dumping into it. That's called an accumulator. Some systems will have that. It's basically knocks off any residual refrigerant in the system and dumps it there, and it can pick it back up. Now, remember I told you about the liquid line dryer. If you look and follow along, you'll see a little gray one. Looks like a little bottle. Looks like it has caps on each end. It says dryer. That is your liquid line dryer. That is your filter. The other one, and I only put those in on systems that are basically designed to reverse themselves. They have reversing valves in them. And that's where I use the sight glass. You can put a sight glass in it so you can see that your refrigerant flows on the high side. So basically, I put sight glasses on heat pumps, and we'll go over that one. Heat pumps, a different dinosaur altogether. It still runs in the same format, but it does something different in a way. So as you go on, you'll see where it's connected to your meter. It goes to the expansion valve, goes to the evaporator, goes over and then back into the compressor. So your evaporator is the one that's inside your home. So if you have a home and your AC system is in the hallway, that's called an upflow. If you open it up, the top part, all you got to do is find the copper lines, the two refrigeration lines. One is smaller, one is larger. One is high side, one is low side. If you grab it and feel it on the high side, it's exposed and it's warm. The one for the suction side, we'll see you'll have this little black armor flex. It looks like a little black tubing that's around it. That goes around it to keep the cooling effect in the tubing. You don't want that releasing out to the atmosphere, because then your system won't cycle or cool properly. So it'll have armor flex on it. And that's how you'll know that that is your low side of your refrigeration system. So to kind of give it a simple breakdown, you have those components. You have your compressor, your condenser, your metering device, your evaporator in a completely sealed system. Now, it is a closed loop system, and what they mean by that is, that means once you charge this system with Freon to the aspect of the superheater subcool that it calls for, it is a sealed system. But let me explain something to you. Copper is porous. Even if you have a system that's been going for 5 years and has not broke a leak, It will leak out some refrigerant because copper is porous. With porous, it will dissipate refrigerant in time, an extremely slow amount of time. After all, everything has changed with Goodman and Trane, Day and Pay and Night and Carrier and all the companies out there. The quality of the refrigeration system nowadays have stepped up their game. Some systems now named like Amana, and a lot of them will have control boards on the outside condensing unit instead of contactors and other devices that are in there. You'll have, your capacitor, your contactor, your voltage leads in on it. You might have a hard start kit or a boost kit that's added to them. Linux has been known to have hard start kits in their system. But we're going to go over those components on the inside and on the outside. There's a lot to cover learning HVAC. And that's why I say this is for beginners, because we're going to break it down in simplicity. I'm going to make it easier for you. I'm going to teach you the real world experiences that need to be known, because a lot of schools, and I know I was an instructor at 2 schools, they overemphasize the book too much. You don't get the hands-on training. But with my videos, we're going to bypass all the trash and get to what really is considered the meat and potatoes of the HVACR system. With the training that I had, I didn't go to school, so I was trained by the old school guys. And the first thing that came out of their mouth when I first went into the field was keep your mouth closed and open your ears and listen to what I have to say. I started out as an installer, helper. Then I became an installer, a lead installer, and then going to be an installer was basically the meat and potatoes and the gold that I learned, because when I became a service tech, I already knew the aspects of the refrigeration system and I knew how it went together. So I was ahead of a lot of other people that never installed. That made me an excellent service tech. So while I was out there installing, our systems would act up or have problems, and it allowed me to diagnose. Being a service tech, you need to be able to diagnose quickly, and it takes time. It's not an overnight process, but you will get to it. But this field pays well. It's a good field. It is a seasonal field. It is slower in the winter than it is in the summer, especially if you're in Texas and Oklahoma and stuff like that. But you can make a whole lot of money within that 3 months. And if you put back, when you get 10 hours less each week going through the summer month or in the winter months, you'll still make it without a problem. You'll have well enough to survive without any issues. I worked and raised 4 boys, and my wife didn't work on just being an HVAC guy. And if I can do it, you can do it. And it pays extremely well. They're paying over $20 an hour easy nowadays. Some of your seasonal service techs or your senior techs like me, you can make $30, $40 an hour. It just depends on what you're doing. But guys, that's the simplicity of the refrigeration cycle. It's real easy. It's real simple. It's basic. If you get a chance, watch it. Go over it time and time again. If you get a chance, go online and type in image of refrigeration cycle, and you can pick that up, and you can use that as a study guide. You can actually see some that are virtual that shows you the mechanism as the compressor works and how the refrigeration flows. There's so many things that you could do nowadays with the internet. So take advantage of that if you get a chance. Guys, I hope you enjoyed this one. This is phase 1 of the refrigeration cycle. We're going to go through phase 2, which is basically learning how to charge and superheat the system and going over your gauges. Your gauges are a big important part of learning how to read them. Not only does it do pressure, but it does temperature readings as well, and you'll need to know that. And I'm going to go in extreme detail with that, because if you don't know how to use your gauges, you're not ever going to learn how to charge or even understand the pressures that are designed for this system. So with that, guys, I hope you enjoyed it. Get with me next time with phase 2 of the refrigeration cycle. We'll see you on the next video.